Okay, all dear students, you stop it and listen here. See, if you have syllabus copy, you have to check it. How much we have to cover the syllabus. I think all of you have syllabus copy, right? So already we started the last unit, that is 8086 different series. Yeah, please. Anyone wanted to ask me? Please all of it open with the syllabus, because right now I don't have a syllabus. I am using different PC. So unit number 8 already we started. From that we covered 80286 and we covered 80386 in the last lecture. Today we are going to cover 80486. Okay. So in the unit number 8, only 3 main microprocessor chips are there. That is different version of 80, 386, 286 and 486. Okay. So just one brief introduction I will give you regarding previous units. In the unit number 1, we studied the introduction and brief idea about 8085 microprocessor in the unit number 1. In that we studied definition, system bus, architecture of 8085, features of 8085 we studied. After that, in the unit number 2, we studied 8086 introduction, features and architecture, along with different kinds of addressing modes we studied in the unit number 2. And in the unit number 3, we studied, that is all the instructions, whatever we used in 8 microprocessor, we have to study minimum 70 to 75 different kinds of instructions in the unit number 3rd. And in the unit number 4th, we have to study, that is system bus architecture. In that, mainly 2 main configurations we have to study, 2 main topics, that is minimum mode configuration and maximum mode configuration in the unit number 4. So this is the first section of syllabus. All first sections we have to cover 100%, right? So next come to the second section of syllabus, section B. In that, in the unit number 5, we studied interrupts, right? So in that, definition of interrupts and different kinds of interrupts, like maskable interrupts, non-maskable interrupts, interrupt service routine, we have to study. So maskable and non-maskable, these are used for to solve the problems, small problems of interrupts. And for the big problems, again we have to study that architecture and block diagram of 8259 microprocessor chip. And this 8259 microprocessor chip is solved between internally for the memory, internally for the different memory. And next one we have to study it for 8257, that 8257 is used for between 2 different memories, between 2 different memories problems we have to solve. And next come to the unit number 6. In that again we studied that peripheral interface, programmable peripheral interface 8255 we studied, right? So this one we have to use it for to solve the problems of 8086 along with peripheral devices program executions. Okay, so those things we have to resolve. We will use 8255 peripheral interface. That is in the unit number 6. And in the unit number 7, we studied completely next version of 8086. Completely next version of 8086 means
Hello, sir.
okay, my voice is mute. Okay, yes, fine. I think my voice is mute. Yes, I think all of you audible now.
Yes, sir. No audible.
Okay, fine. So, in the unit number 8, we are going to study different versions of 8086. That is 286, 386, and 486. So in that I covered 80286 and 80386 in the last lecture. So today I am going to cover that is 80486. So this is the last topic for your theory syllabus of this semester. Am I right? So today I have to start from today's lecture 80486. So in that also just we will in the unit number 8, whatever we study is three different versions of 8086 means 2, 4, 2, 3, 4. Okay, that is just you studied for architecture, features, architecture of block diagram, and modes of operation, functionality of particular version of microprocessor chip. This much you have to study, more than enough. So here, come to my screen, shared screen. Please look into that. I have to prepare the slides for you. So here in the 8086 microprocessor, the 32-bit of 8086 microprocessor, it is used a 32-bit, and that step up from the 80386. Why it is 32-bit? So it's the next version of 8086 because 8085 we have to use it 8-bit. 80486 we have to 8086 we have to use it 16-bit, and this next version means double of that we are using 32 bits. So all these versions are used for 32-bit of 80486. So one of the most obvious features in the included here, that is built in with the math processor. So math processor means whatever the mathematical functions are there. Mathematical functions means like trigonometric functions, sine, cos, cosine, tan. So all functions are added into this function. All functions, mathematical different functions are added into 80486. So it is easy for to resolve mathematical functioning things. Okay. So and in this integrated a chip allows to execute math instructions about 3 times faster than 80386 and 80387. So for that 80486 is more advantages over than 286 and 386. So one more main key feature is in the 80486, it is 8 kilobyte code and data cache is there. Data cache means what? That much temporary data is holding capacity of 80486. So in the 80486, the additional signals like packaged in 168 pins. So this is for 168 pin, and that package instead of 132 pin with the programmable grammatic arrays used for the 80386. It means that totally the 80486 have more features over than 80386. So this is the one architecture, but all of you just you go through it. Anyhow, all of you have a objective type questions in the examination. This architecture they didn't ask, but for your kind information, you just go for all the different blocks. Here in 80486 having more blocks due to solving the functionality of mathematical functions here. So floating point unit is also there. That barrel shifter is there, register file, arithmetic and logical units. So here there is a data bus transfer, bit rate, that is bit data bus, and segmentation of units, descriptor, register, and limit and attributes of program PLA, that is algebraic controller, and linear address bus, paging unit, translations of uh, look aside buffer, catch unit, that and perfector, byte code queues, instruction decode, control and protection of test units, control room is there. So here at the right side, all the bus interfaces like address drivers, write buffers, data bus transceiver, bus controller, request segment sequencer, bus to bus control, bus size, control cache, control, and all these parity generation and controls. So these are the different blocks. That much is not essential for you, just for you understand the features of this 80486. And along with that, whatever the pins are coming here, different functions, different kinds of pins is used in the 80486. That one you have to just carry on. So all pins I have to explain here with the pin definitions. Okay. So in this pin definitions for 8 address lines, because here it is 32 address lines are used, 32 bits. So A8 to A31 address outputs are used to provide the memory for input and output with address during the normal operation. And also during the cache means what? Temporarily storageable purpose, that invalidation of A31 to A4 are used to drive the microprocessor. Okay. And here that A20 to M3, M3 means memory. So here the address bit of 20 mask causes with 80486 to wrap its address around the location of, this is the one location memory address is given from 00 to FFFFH, means 5F, 000 5FF. That much memory has in the 8086 of is usable in 80486, and this provides a memory system that functions like one memory byte. Here that M3 indicates that memory bytes real memory system in the 8086 processor. So here we have to use it ADS in the sense what? It's a address data store. So the address data store becomes a logic 0 to indicate that the address bus contains a valid memory address. If the logic bus is containing a 0, it means that it is containing a valid memory address. So this is the one pin configurations, that different kinds of pins are added here, all VCC, VSS, address lines, data lines, just it's not need for you. So next that is hold acknowledgement, hold A or A hold. That one is for the address holding input causes with the microprocessor to place its address bus connections at their high performance state. with the reminder of the buses staying active. Okay. So hold acknowledgement, what it will do, whenever the request is sending, it is get responses from the host to the host and resolve it into that. And it is often used in another bus master to gain the access for a cache invalidation cycles. So that bus request means bit request. In this, the it is a bus request. Output indicates that the 486 has generated an internal bus request. So next pin is B0, BE0 to BE3. So this is the byte enable. BE means what? It's a byte enable, and here the outputs select back of the memory system where the information is transferred between the microprocessor and the memory and along with input and output devices. So the bus enable signal enables the total 12 bits, 24 to 31 means 10, 24 to 31 means 8 bits bus enable, which can 16 to 23, 8 to 15, and 0 to 7. So 0 to 7 is 8, 8 to 15 is 8, 16 to 23 8, and 24 to 33. 8 plus 8 plus 8 plus 8 is total 32 bits of bus enable. So next, that B last means what? Burst loss output shows that the bus cycle is completely on the next activation of bus ready, that bus ready signals. And that B off, it's a back off input causes the microprocessor to place its buses at the high impedances state during the next cycle. So the microprocessor remains in the bus hold state until the bus off, that back off pin is placed at the logic level 1. So next one is that is NMI. NMI already studied in the unit number 5. That is hardware, one type of hardware interrupt, that is non-maskable interrupts. So these non-maskable interrupts are used for to resolve the small fault difficulties or problems occur during the execution of programs. That's with the type of two interrupts. So next one is burst ready. B ready means it is a burst ready input is used to signal microprocessor that a burst cycle is complete. So next one is cache enable. KEN means it is a cache enable input that causes the current bus to be stored in the internal memory. So next pin is L lock, means lock output becomes a logic 0 for any instructions that is prefixed with the lock prefix. So next one is WR means what? Read and write, write and read. So that current bus cycle is either a read or a write, it is decides. Next one is IGNNE. It is ignore numeric error. Whatever the errors is happened by the numeric problems, that is ignored in the input cases, that coprocessor to ignore floating point error and to continue processing data, as well as the signal does not has to update the state of P errors also. So in the P flush, that F flush or flush, the cache of the memory flush input forces a microprocessor to erase the contents of its 8 kilobyte internal cache that is managed. So at the last, uh, that external address stove EADS means external address stove input is used to hold the acknowledgement to signal to that of external addresses is used for to perform a cache invalidation cycles. So next one, that floating point error means FERR. This input output indicates that the floating point coprocessor has detected an error condition, and it is used to maintain compatibility with DOS software. DOS means disk operating system software. So next pin is BS8, that is bus size 8. Input causes the 80486 to structure itself with an 8-bit data bus to access byte-wide memory and input and output components here. So next one, the BS16, that is next 8 bits, means bus size is 16 bit, which is cast the same 808 486 structure itself with a 16-bit data bus to access worldwide memory of the input and output components. So next pin is P-check, means parity check output indicates that is parity error was detected during read operations on the data P0 to P3 pins. P-lock is over, I think. So it is parity lock or pseudo lock that output indicates the current operation requires more than one bus cycle to perform. So for performing more than one bus cycle, they have to use it for pseudo clock. So this signal becomes a logic zero for arithmetic processor operations that access 64 to 80 bits memory of data. So next one, that is PWT. The pace PWT means pace write through output. This indicates the state of the PWT attributes bit in the pace table entry or the pace directly entry. So next ready, all of you know that ready state is used for once the data is get ready, that input indicates the non-burst cycle is complete. So the ready signal must be returned or the microprocessor places wait states into its remaining timing until the ready is asserted. Once the data is get ready to execute, that ready signal is, if it is zero, then it is either the executed state. If it is one, then it is in the up states. So that memory input and output defines whether the address bus contains a memory address or in the input and output port number. So it is also combined with the read and write signal to generate a memory and input and output read and write control signals. So this is the different kinds of pins. Only in this topic, just we have to go through that architecture and this the pins functionality. Particular pins is what is the function of in this architecture of 80486. So this is your entire syllabus. Whatever, please go and check. I think by the today I have to complete all 100% syllabus. So now onwards, what we will do? Every day we have to go for revision, and every day we have to go for one class test. So in a week, I have to get in one lab and two theory classes, right? One theory class is for 2 hours, one class is for 1 hour. So what we will do? Every day we have to fix one module, means one in it. Every day you have to go and study one in it and make a points. List out the points. What are the difficulties you are facing in that particular unit, or if you have any not understand concept is there. So we have to discuss every day on that. Okay. So anyhow, we have to complete it the syllabus first way of syllabus, and in the next way of syllabus, we have to do the revision. In that revision, so in the first round, I think the some of students are may having not understood some of the concept, may what I may feel. So those kind of things you have to make list out, you have to make a points, and whenever we are going to start revision on that particular unit, that time you have to raise the face of those listed points, means whatever you are facing the difficulties for that particular unit. So like that, again in the second round, we have to resolve 100% your problems. I think this first round you may perfect with some 70 or 80 or 85 something percentage. Okay, so in the second round, remaining whatever the non-understandable or any other difficulties concept is there, that one also we are going to resolve it. So In next class, next lecture onwards, we have to follow it. And in the lab also, I have to completed 9 programs. And in the last program means 10th program I given to you program code, and many of the students are executed. I'm very happy for that. That string display and reverse string, many of them they are executed. Even if some students are not executed, also not a problem. In the tomorrow lab session, that program again I have to revise it. String display and revision of string. So by the tomorrow, also we have to completed all the 10 experiments. But as your syllabus, in the syllabus they are clearly mentioned that uh, 8 to 10 programs we have to study. Okay, you go and check in the syllabus. At the first line only he is mentioned 8 to 10 programs. But we have to do study all the 12 programs because we have a lot of time. Your exams is still in the I think in the month of March maybe. Okay, so still we have a lot of time. All the programs also we have to cover, and we in the lectures we have to do the revision of all 8 units. Okay, so in this way we have to cover it. And for your exam point of view, all of you more concentrate on the unit number 2, 3, 5, 6. For your exam point of view, 2, 3, 5, and 6 are very, very important. And even first unit also bit important because it is the concept of 8085. Okay. And this unit number 7 and unit number 8, these you have to put last priority for your study purpose. That much many will not get it. But in the previous up to 6 units, you have to get it almost your 90-95% of the objective type questions. Okay. So objective type means multiple choice questions. I given you already from the unit number 1 and 2, and from unit number provided in number 3rd MCQs, and unit number 7 and 8. So unit number 7 and 8, I have to transfer you today only. Just for 1 minute. Okay, within today evening, already I have to prepare the MCQ on unit number 7 and 8. So only that MCQ I want to add it 8th unit of today's topic, means 80486. So within today 8 p.m. all of you get it MCQ questions of unit number uh, 7 and 8. Okay. So and if we have to provide it 7 and 8, remaining 1 unit is remaining, that is unit number 3rd. So why I didn't prepare for unit number 3rd is, in the unit number 3rd, everything is instructions only. There is no any theory concept is there, instructions only. So separately, I have to prepare the MCQ on the instructions chapter, means 3rd chapter, and within 1 or 2 days, that one also I'll give you the MCQ questions. Okay. So by today, you will get it all 7 models except 3rd units. You will get it all the MCQ questions. So in this way, we are going to cover it. And in the next, my one part is over. In next lecture onwards, every day you have to go for 1 unit to study. And based on that, you will note down. You have to point out the difficulties or any not understand concept. That one you have to come and discuss with. So that is totally open for discussion to each and everyone. We have to clear the concept of in front of everyone. Is it okay? So because of my syllabus is completed, so I will stop it here, my today's lecture. And see, actually, more effective is now onwards. In now onwards, don't miss the any lectures because we have to do the revision. In that revision, you have to understand a lot of concept. Real concept you have to understand because already you know that first round of syllabus actually what is the syllabus. In second round, you have to understand even every corner point of point also you have to understand about the subject. So now onwards, you don't miss the lectures. Okay, I have to take a pause it here. Otherwise, if anything you wanted to say, please, it is open discussion for 20 minutes. You come up and you have to discuss. Something you want to say, anyone, please? Raise the voice. Okay, if no any voice means I have to take a pause here.